student, let's try to understand atmospheric refraction. You might have observed the apparent random wavering or flickering of the object seen through the turbulent stream of the hot air rising above fire or radiators. The air just above the fire becomes hotter than the air further up. The hotter air is lighter, less dense than the cooler air above it, and hence refractive index slightly less than the cooler air. Since the physical condition of the refractive medium air are not stationary, the apparent position of the object as seen through the hot air fluctuates. This wavering is thus an effect of the atmospheric refraction of light by the earth atmosphere. On a small scale, in our local environment, the twinkling of a star is similar phenomena. On the much larger scale, let us see how we can explain it. So, twinkling of a star, student. The twinkling of a star is due to atmospheric refractions of the starlight. The starlight on entering the earth atmosphere undergoes refraction continuously before it reaches the earth. The atmospheric refraction occurs in the medium, gradually changing in refractive index. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from the actual position. The star appears slightly higher than its actual position when viewed near the horizon. Further, this apparent position of the star is not stationary but keep on changing slightly. Since the physical condition of the earth atmosphere are not stationary, as was the case in the previous paragraph. Since the stars are very distant, they are approximately point-sized surface of light. As the path of rays of light coming from the star goes on varying slightly, the apparent position of stars fluctuate, and amount of starlight entering the eye flickers. The stars sometimes appear brighter and sometimes quite fainter, which is the twinkling effect. Why don't the planets twinkle? The planets are much closer to the earth and are thus seen as extended source. If we consider the planet as a collection of a large number of point-sized sources of light, the total variation is the amount of light entering in our eyes from all the individual point-sized source will average out to be zero, therefore nullify the twinkling effect. Advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of the atmospheric refractions. By the actual sunrise, we mean the actual crossing of the horizon by the sun shows the actual and apparent position of the sun with respect to horizon. The time difference between actual sunset and the apparent sunset is 2 minutes. The apparent flickering of the sun disk at the sunrise and sunset is also due to the same phenomena. Scattering of the light. The interplay of light with the object around us give rise several spectral phenomena in nature. The blue color of the sky color water in the deep sea, the reddening of the sun at the sunrise and sunset are some of the wonderful phenomena are familiar with. In the previous class, you have learned about the scattering of light by colloidal particle. The path of beam of light passing through true solution is not visible, however, part become visible through the colloidal solution, whereas the size of the particle relatively larger. Tyndall effect. The earth atmosphere is heterogeneous mixture of the minute particle. These particles include smoke, tiny water droplets, suspended particle of dust and molecule of air. When a beam of light strikes such fine particle, the path of beam of light become visible. The light reaches us after being reflected, diffused by these particles. The phenomena of scattering of light by the colloidal particle give rise to Tyndall effect, which you have to study class 9th. This phenomena is seen when the fine beam of sunlight enters a smoke-filled room through the small hole. Thus, the scattering of light makes the particle visible. Tyndall effect can also be observed when the sunlight passes through the canopy of the dense forest. Here, tiny water droplet in the mist scatter the light. The color of the scattered light depends on the size of the scattering particle. Very fine particle is scattered mainly blue light, while particle of the larger size scatter larger wavelength. If the size of the scattering particle is large enough, then the scattered light may even appear white. Why is the color of the sky appear blue, color of the sunrise and sunset? So this is what is the phenomena, student. Thank you very much for watching.